So now we're going to CAD the wheel modules for this drive base. Okay, and we're going to start on a new component. So let's flip that solid. You aren't on solid. Activate your main file. Create a component. Okay. Why we're activating the main file now is so that when I create this new component, it will be created under the file, so it won't be within structure, it will be beside structure, right? And I'm going to call this wheel module. Okay, like that. All right, cool. And this is going to gray out everything else you have here in your file, okay? And that's just normal. It's something you deal with, okay? You can still interact with it. You can still point to all of these pieces, but it will be grayed out. Okay, yeah, I accidentally turned that off in the last video. So we want to turn back on all the sketches. Okay, so we can point to point easily. All right, so now we have wheel module activated, and we're going to get familiar with all sorts of other parts. Okay, so this structure is just providing the frame of the robot, right? But we need wheels, and we need motors, and we need axles, so we can actually move this robot around. Okay, we can start with the motor. Electronics. Okay, it's loading for me. Give it a sec. This is not all the pieces here. There we go. Okay, and we're going to take V5 motor LS shaft. Okay, why we're doing this one instead of just a normal V5 motor is because it comes with the axle in it. Save us a bit of time while we're CADing instead of having to import both pieces. Okay, so now I have the motor imported like that. Right, and it's the same deal. We got to point this motor to a piece on the C channel. Okay, so maybe I didn't say this earlier. There are times when you like free move things in a position. Okay, that's usually when you've already point something. So all the C channel earlier, right? I had rotated one of these C channels and put it at an angle, and then I pointed it to the C channel, right? But if it's in the same orientation, a piece, and you simply need to translate it, then you can use free move to move it in increments because all these holes are spaced 0.5 inches apart in a grid, right? But in this case, we don't know what this exact distance is from the motor to the C channel, so I'm going to use point to point. Okay, and I want this axle to go through this center hole here, okay? But I'm not going to point with the axle. I have to point with the motor mount where the motor actually contacts the C channel. Okay, and this space here is one hole to the left of the axle. Okay, when I'm pointing, be very specific about where you point. Do not use the end of this yellow thing. Okay, you want to use this surface. Okay, it doesn't actually matter which circle you use. When you're pointing, if you click on the edge of a circle, it will actually select the center of the circle for you. You have to see where that blue highlight's going. The blue highlight's right now going to that cross, so we know it's in the center, right? But if I were to do, like, I don't know, I'm using this as an example, right? We can see the blue highlight is going to the center of this surface, over here of this axle. Okay, so you have to look at where the blue highlight is to know what point you're actually clicking on, even though your mouse could be very far away from the point. So if I'm on this circle or this larger circle, it's the same point actually, because these circles share the same center. Doesn't matter. Usually I go with the bigger circle because it's easier to like click on from a distance, right? I can accurately still click on it. Another mistake with this click is that sometimes people will click on this other circle here. Okay, you'll notice it's not actually on the surface of it. It's like a bit further back. You want to make sure you're on this surface, clicking on this circle. Okay, So we click on that circle, and then I want the motor axle to go through here, so I'm going with this point. Okay, I'm zooming in a bit more to make sure I'm clicking on the closer point, not the further point, so the motor does not go into the C channel. Okay, so there's no overlapping surface. All right, and I can click OK. And this axle, we want it to be 2 inches long. Right. All right, so now we got the motor installed. Motors receive electrical power from the cortex and battery and spin things, if anyone was wondering. Okay. Hope most people know that. So, okay. Now we're going to get introduced to a few other pieces. Okay, there is hardware where we have shaft collars and spacers. Okay, and bearings. Actually, first I'll talk about bearings. So okay, I'll activate the whole file so it's easier to see everything. All right, let's look at these holes in the C channel. Okay, they're very squarish, right? And now we actually have an example of an axle here, which is also very squarish. Okay, and you try to turn a square in a square, that is not going to be that's not going to allow you to turn smoothly within the hole, right? So we put in these pieces called bearing flats. Okay, and you put them on the C channel, and you while we're CADing, okay, usually we do not CAD screws and nuts because they're understood by whoever's building the robot usually. It's just being there, right? But yeah, okay. So we're not going to actually CAD the screws and nuts, but what would actually be happening in real life here is the axle goes into one hole of this bearing, okay, and that creates this circular hole that the axle can smoothly turn in. Okay, and then the other two holes are filled in with screws and nuts to secure that bearing flat to the C channel. Okay, another just general engineering rule is that shift something there. Okay, another general engineering rule is that you want to, or I made a mistake. Okay. Always make sure your correct component is activated. I did not activate wheel module just now. Okay, so this is part of the wheel module component. Okay, so that engineering rule, you always want to support an axle in 2 places, right? In theory, while this loads anyways, we have these 2 C channels here, right? And you could theoretically choose to just use this inner C channel on the left, right? The motor is mounted to it, has the axle sticking out. You could just put the wheel here, and your robot would still move, right? But because the axle is not supported, it's actually going to bend upward a bit at an angle. This won't happen in the CAD, but it would happen in real life. So it's a general rule that you always support every axle in 2 locations. Okay, and that includes the usage of bearings in 2 locations. You can't just simply have the axle go through 2 C channels, but there's only 1 bearing on one of the sides, right? That doesn't work so well. So I just rotated the piece, right, and I switched to point, and then I can put in the bearing flat over here. Okay, and it's in the wheel module component. Okay, bearing flats you almost never modify, so I can just copy paste it, right? Not going to use the modify tool on it too much. don't think it would even work. I mean, there's situations where you might cut off one of the holes of the bearing flats just so that it can fit in some kind of tight place, but that's not the case here. Okay, so now we're going to point it here. All right. Okay, and we got both of our bearings in. Woohoo. Okay. And so yeah, now this axle is properly supported. It goes through 2 C channels and a bearing at each point of contact with those C channels. Okay, so this axle is fully supported. It's not going to do weird things like bending up and down, and the wheel will turn smoothly. Okay, so something else to keep in mind is this axle, in real life, can slide around left and right. Okay? And what does this mean? Right now, if you tried pushing it left, it would just hit into the motor, okay? And the motor wouldn't fall out because we'd have 2 screws here holding the motor in place, right? So that's fine. But let's say your motor tries to shift to the right, okay? It would then be able to simply fall out, okay? And that's a problem for us. So we're going to use this piece called a shaft collar, okay? And we're going to use the CAD file is ls shaft collar with the set screw. Okay, I'm going to insert in a current design. Okay, and I'm pointing it to here, like that. Okay, so as a shaft collar, it has this screw here, okay, and you turn it down and it pushes the screw to the side of the shaft, and then it kind of acts like it's attached to the shaft at that place. You might think of it as like the axle ballooning up and getting a wider diameter at that place, okay, at the location the shaft collar is at. Okay, and then so now when you try to push the axle to the right, okay, because the shaft collar is dug into the axle, it's not going to be able to move to the right. It's just going to hit into the C channel, and that's good in this case. The axle will stay exactly where we want it to be. It won't fall out of the motor. Okay, that's a pretty important thing. So you have to, use logic, and wherever you have an axle, think if you have shaft collars in the right place to prevent the axle from falling out. Okay. If I ever refer to the axle as a shaft, it's like the same thing. Okay, axles and shafts are the same thing. Just to clarify that. Okay. Now we're going to import the next part. We're going to motion wheels. Okay, and we're going to import 4-inch Omni wheel. Okay. So Omni wheels are interesting. Okay, traction wheel is like a standard wheel that you would understand. The Omni wheel has many tiny wheels pointing, what's the word, like horizontally across the wheel, not in the direction the wheel is spinning. Okay, and what does this do? Because the wheel is set up this way, it allows us to turn very easily, right? This wheel can either go forward and backward, and it can slide freely left and right because it has all of these, they look like rollers, they're small wheels, okay, inside the wheel. Okay, and that just lets your robot turn very easily. Yeah? All right, so I'm pointing. So this one you have to be careful. Okay, I'm going to clarify this. You want to see, you see this black insert piece here? Okay, you want to click on this surface and click on this outer circle, which will select the center of that. Okay, and we're going to point it to the shaft collar, like this. Okay, and I'm going to click OK. And this is the modify menu pulling up from here. Okay, and there's different inserts you can use. In this case, we want the square insert. Okay, just a detail. No insert would mean this hole becomes bigger and actually fits a different kind of shaft, a high strength shaft, which is a lot wider. Okay, and use when you need to use it, when you need a lot of strength, but dry paste doesn't. This round insert creates a round hole inside the wheel. Okay, and now lets the wheel freely spin. But in this case, we want a square hole because when the axle turns, we want this wheel to also turn so the robot gets pushed around by the motor. Okay, so I'm going to click OK for that. Right. Okay, and then I am going to insert a spacer because while the wheel can't go any more to the right, it could move to the left a bit. You want to fill in that space. It's not necessary to put in a shaft collar, and we have limited number of shaft collars, so use spacers when you can. Okay, something else to note. When you're CADing your own robot, just keep in mind the only spacer we have large quantities are the 0.375-inch outer diameter spacers. Okay, so I'm going to insert this in the current design. Okay, so I move it here just so it's a bit closer before I start using point to point. We can actually tell which direction the spacer is facing by looking at the move menu. Right? You want to pay attention to this arrow that is pointing out from one of the surfaces, one of these giant flat surfaces of the spacer. Right? Right, so we know it's pointing this way so that later when we switch to the modify tool, after we finalize its position, it's going to extend or retract in that direction. If you don't know what I mean, you'll see in a sec. I'll point the spacer from there. If it's hard for you to access this point, you can expand the wheel module and just hide the wheel so you no longer see it. Okay, because the axle's there, might be a bit difficult to click on the point, so you can put your mouse over the surface, okay, and then hold Command, and then you can click on the points on the surface. Okay, if you're on Windows, the button would be Control. Didn't quite work out. Okay, we're gonna hide the motor then. Put it there. There we go. Okay, and you can bring back in the pieces. Okay, and we'll click OK. And for some reason, the default is 0.128 inches. You could go with that length, but in order to accomplish that, we have these standard sizes, as indicated here, and you would have to manually sand down the length of the spacer to fit. Okay, and since it's 0.128 inches, you would have to start with 0.25 inch spacer and sand down that amount to get to 0.128. Okay, in this case, we're going to go with a 0.375 inch spacer. Okay, and I'll fill up all the space. Okay, and yeah, there's a small gap there, but oh well. Okay. All right, and we got the module done like that. Okay, and now we're going to activate the entire file. And one way you could do this, though it'd be a bit inefficient in CAD, is do that again 3 more times for each of the corners. But because we set up the file this way, and we have a wheel module like that, okay, we can just copy the wheel module. Now we have another wheel module component. Okay, put it here. I'm going to rotate it around so it's in the correct orientation. The origin of the component is like weird. It's like over there, but don't worry about that. Okay, and we're going to point to point the motor. Okay, click the outer one. So that's 2 holes over. Point to point the motor there. Right. Okay, and there we go. Drag this is starting to come together. Okay, and I can click both of these. Again. Rotate them all the way around. Pull it up just a bit so it's easier to access the point to point. And you can even do it with a bearing, right? Like, it's a very versatile tool. I'm going to do it with the bearing, which means it would line up with this hole. Okay, and all the pieces we have selected, right, will move together while you're doing point to point. It doesn't matter you're clicking on one surface of one piece to, like, I mean, wherever you want it to move to, right? It will move all the pieces you selected by the same amount in that same direction. Okay, we can click OK, and there we go. Now, I intentionally made a mistake to demonstrate something. If you might have caught this earlier, right? And you should check over your file to see if you made any other placement mistakes. But you will notice that this spacer is actually inside the C channel. And oh no, now I have to fix this, right? I have to make it, actually, okay, it's not even only that. It's like, it's all messed up. It's just not in the correct place, okay? And, well, we can actually fix this. So I'm going to go back into this piece, activate it, okay, double click on it, I'm clicking M to move it. I'm going to click this here, point to point. Okay, move the motor. To this point. Motion position. All right, and then it's going to move the piece there. Okay, and activate the piece. Okay, and oops. Okay, show the motor again. Okay, and now it's actually not interfering here. Right, it's actually on the surface of C channel as it should be in real life. Okay, so that's how it looks on this module. We can go check on another module and see if it works properly. And you will see that it actually doesn't, annoyingly. It's still out of place. Okay, so we have to do one more step to fix this. We go back, activating this piece, this component. Okay, and I'm going to introduce you to a new tool. Okay, you can either right click and find the rigid group button, or you can go to create and modify. Like, I don't remember where it is, sorry. Okay, you just right click on it. Okay, and we can pull up this menu and click on rigid group. Okay, if this ever appears, always click yes. And click OK. All right, and now we have a rigid group. And what does a rigid group do? It makes sure all the pieces within the group are positioned exactly the same relative to each other. And because we applied this change to one of the components, this is similar to how like the modify tool worked on the C channels in the previous video, right? Now go to another file, and that same rigid group is going to be in it. And so guess what? I'm going to go over here now to the second wheel module. I'll hide the wheels so we can all observe. we can see that the spacer is in the correct place, okay, like in the first wheel module, right? So that's what a rigid group does. It keeps everything rigid, okay? Like now if I, for some reason, decide to move one piece, the spacer, right, within this rigid group, all the pieces are going to be moving together because that's what a rigid group does. It makes sure all of the pieces within the rigid group are always the same position relative to each other. Okay, don't actually want to move it, so I click cancel there. All right, so we got all of that rigid grouped. Okay, something else I'm going to demonstrate that's a bit funny. Okay, you'll notice I had to capture the position of this piece, and then I had to rigid group it to make that change apply to all the other pieces. Okay, but let's say, I don't know. Let's say we want to add a shaft collar out here, okay? You wouldn't actually do this in real life because this shaft collar is totally useless. It doesn't do anything. Like the axle's not going to fall out that way. But let's say for some reason you wanted to. Okay, and I activate this component. And now I'm going to find the shaft collar. Collars. Okay. Okay, and I have this wheel module activated. Okay, in that case, I could have actually copy pasted, but whatever. Okay, you'll notice. Look. There's some other copies of it moving around, and why is this? It's because it exists in this component. It's also existing in those other sister components. Okay, I'm modifying one. This modification is applying to all the others. Now, something else that's interesting is while I move the piece in this state, right? Earlier I moved the spacer after I'd already entered its initial location. Okay, so it didn't change. So after I moved it after logging its initial location, it didn't update for all the different pieces. So I had to go create that rigid group, right? But when you first import a piece, you are logging that initial condition position. That's why the capture position sign never appears, because the way Fusion 360 processes it is that wherever the piece is by the time you click OK or click Enter, that is where the piece appeared out of nowhere in the file. Okay. So let's say I want to put it here, right, and I put it over there, okay, on the end of the axle, right, and I click OK. Okay, it's going to look exactly the same for all the other pieces, all the other components. All right, so that's pretty cool. And there we go. I mean, one slight interesting thing is that we'll see it's a very, very small gap. You know, in real life, it's possible that this wheel would contact the C channel. Okay, but I mean, I've built this exact drive base before, and for some reason, it doesn't actually do that in real life. But yeah, okay, we have actually now finished complete drive base CAD. Okay, so you go ahead and save. So normal standard procedure. Okay, we go here to project visibility, turn off sketches. Okay, we would also usually turn off joints. Okay, in this case, we'd have to go through one by one. Switch off joints. Okay, why is this joint here? What is this part of? Here. Go to motor. Joints. Okay, there we go. Right, and now we have a very clean looking photo to take. Well, this is a good enough angle, so I'll use Command-Shift-4 because I'm on MacBook Air. All right, and I got that photo. Okay, and I'll save the file. I already saved it just now, so it's fine. And there we go. We have now finished a drive base.